Welcome back to the Hardware Core. This is your destination for deep, data-dense technical breakdowns and raw hardware architecture. For over 3 decades, PC memory has looked exactly like this: vertical plastic slots, gold fingers, and long circuit board traces. But traditional DDR5 is officially hitting an electrical brick wall. As we push speeds past 8,000 megatransfers per second, the physical distance between the CPU and your RAM slots introduces signal degradation that no amount of voltage can fix. Enter Desktop CAMM2. This isn't just a layout shift, it is an entirely new architectural foundation. By mounting flat against the motherboard and using compression pins instead of slots, CAMM2 promises to unlock speeds beyond DDR5-10,000 out of the box. But this paradigm shift comes with massive platform trade-offs. Today we break down the signal physics, the raw performance gains, and the brutal upgrade tax that might make you think twice before buying a next-gen motherboard. Every traditional motherboard you've ever built and relies on a dual-slot or 4-slot vertical layout. This requires complex circuit board routing. The electrical pulses traveling from the CPU memory controller have to fight through trace length variations, crosstalk, and empty slots that act like open-circuit antennas, reflecting data signals backward. Desktop CAMM2 obliterates this trace length problem completely. By removing vertical slots entirely, the module interfaces with the motherboard via a land grid array compression connector directly next to the CPU. The distance data travels is cut by up to 70%, eliminating signal reflection and giving motherboards unprecedented electrical stability at hyper-high frequencies. Even better? A single CAMM2 module natively populates the entire 128-bit dual-channel memory bus. You get full dual-channel performance from one single ultra-thin piece of hardware, turning the physical foundation of desktop memory upside down. What does this structural signal integrity actually unlock for real-world performance? With standard DDR5, achieving a stable 8,400 megatransfers per second is an absolute lottery. It requires elite silicon binning, expensive multi-layer motherboards, and perfect memory controller voltage matching just to boot into Windows. Desktop CAMM2 clears that hurdle effortlessly. Engineering test platforms are already running stable, consumer-grade CAMM2 modules at DDR5-10,000 and higher, right out of the box. No extreme voltages required. Because the module sits entirely flat, it completely eliminates the airflow blockage created by giant, vertical RGB heat spreaders. The flat horizontal form factor means you can mount a dedicated memory heatsink right into the case's standard airflow path, dropping operating temperatures by up to 20%. For elite overclockers, workstation professionals, and high frame rate gamers, CAMM2 represents the largest pure memory speed scaling loop we've seen in a generation. But do not buy a next-gen motherboard just yet, because Desktop CAMM2 introduces a brutal upgrade tax. In a traditional system, if you buy 32 GB of RAM today and need 64 tomorrow, you simply drop 2 more cheap matching sticks into your empty slots. With CAMM2, that workflow is completely dead. Because one single CAMM2 module completely occupies your entire physical memory bus, there are no empty slots left over. If you need a capacity upgrade down the road, you cannot add more capacity. You are forced to unbolt the socket and completely replace the entire module, rendering your original, expensive hardware obsolete. Add in the steep early adopter premium for both the unique motherboards and the modules themselves, and the consumer calculation shifts. If you are an elite overclocker chasing world records, CAMM2 is the unquestionable future of high-speed performance. For standard desktop users and budget system builders, secure, reliable, mature vertical DDR5 kits while this platform matures over the next few hardware cycles. Drop your thoughts in the comments below. Is signal integrity worth losing your DIMM slots over? Hit that subscribe button for deep, data-dense technical breakdowns. This is the Hardware Core. See you on the next upgrade cycle.